So on the GIF, a really nice sort of picture of the foot. With the tarsal bones color-coded. So you can see the calcaneus in yellow, the talus, I guess that's pink, red for the navicular. The medial cuneiform is in green on the inside, so medial, intermediate, and lateral. And finally, the purple bone on the outside is the cuboid. So the take home here is just how complicated that thing looks. And B, the arches. So there's your medial arch, medial longitudinal arch, and there's the lateral arch. So we spent a bit of time talking about that, as well as all the muscles that are embedded underneath here. The difference between the hand and the foot is this is meant to obviously carry load, heavy load. So mid-strike while you're running is more than your body weight when you hit the ground. So due to gravity, it's got to be pretty strong stuff. So the calcaneus is usually the one that takes the brunt of the distribution of weight back to the heel. But then the talus, after it does pushes weight that way, the talus actually has to push weight through the navicular and then onto the forefoot as well. So a third of your weight goes that way, 2/3 goes backwards into this arch. So we're going to talk a lot about the arch itself, and the dynamics of this really help you walk efficiently. Okay. Where we've been, where we're going, just review the written acronym as well. Talk about the tibiofibular joints. So unlike in the upper limb, there's more mobility with supination and pronation happening. These are fairly restrictive joints. The fibula kind of goes along for the ride in us because we're bipedal. Talk about the ankle joints and the ankle ligaments, and then finally again ligaments of the foot as compared to the arches, and maybe if time permits, a little bit on what happens when things break. So review again for your lab exams, not next week, but the week after. You have to come to the lab you've been assigned to. And so if you're Monday, Wednesday, or Thursday slots, usually your lab would be 2 to 4. Be ready to go at 2:30 at the back door. Because we'll let you in, you're gonna drop your bags, your phone's already off in your bag, your computer's off in your bag, just a bunch of pens and pencils, and your brain, and a water bottle if you want to bring it with you. What usually happens when people bring water bottles is they leave them at a station. And then I'm not gonna have you go back and forth to get water bottles, so it just stays there until the end of the exam. Okay, come in then. If you're on the Tuesday section, you're gonna come for the first lab, we'll start you at 3, and then we'll start the second group at 4. And on Friday, instead of right at 8, we'll be there at 8:30. Be ready to go. Because again, once the chain starts doing the exam, the door's locked and I can't let you in. Okay, so be sure to be on time. So there won't be any lectures the week of the lab exam, the 28th to the 2nd. So the 3 lecture slots in that week we won't have. Don't need them. Debating what we'll do with the last 2 lectures in early or December, I guess it would be 5th and 7th or something like that. How we'll handle them is just a tutorial or a review, okay? And again, it's been determined that the Student Recreation Center C area is going to be your exam, your final exam is on the 17th. Starts at 8:30, bright and early. Last class, we did talk a bit about these posterior compartment muscles in the lower leg, how they can be easily divided into 2 layers. Moore does this quite nicely. More superficial layer, the critical ones are medial and lateral gastrocs, and how they join their tendon with soleus. So you end up with 3 heads coming down as the calcaneal tendon and inserting into the calcaneus. The difference is the soleus, big, broad, and thick muscle, will only be a plantar flexor. Gastrocnemius, both medial and lateral, take their origin above the knee from the posterior aspect of the femur, so they can also flex the knee joint, so it's a biarticular muscle. The 2 of them together amount to about 90 to 93% of your power force of calf muscle. And in a cat, the soleus is 100% what's called slow twitch. And it's meant to make contractions for long periods of time, but not generate a whole lot of force, whereas the gastrocnemius, heavily fast twitch muscle, it's your jumping muscle. Okay. So they have different roles, but they have a common tendon attachment. tiny little muscle called plantaris, very minimal in size, takes its origin above the knee joint, so technically it's a knee flexor, comes down and attaches to the Achilles. You can even say it must be a plantar flexor. But it's really tiny in size and has this very long, rather compliant tendon. Now Moore says it blends in with the Achilles tendon, or calcaneal tendon. As I said, what Moore says is right. If you look in the skeletons, you'll notice that there's a little blue dot just in the medial side of the calcaneus. So it's the insertion of plantaris. It is not a part of the calcaneal insertion. Why he says that, I've never seen it on a cadaver. I've always been able to dissect it out, find it down, and it's on the inside of the calcaneus, not on the Achilles. Why they say that. So these four, plantaris, and the three heads of triceps suri are the superficial group of the posterior aspect, all supplied by deep tibial nerve. Okay. Remove them, get them out of the way. You have four muscles left. We have popliteus, which we've talked about before. Actually takes its attachment from the lateral aspect of the condyle of the femur, crosses obliquely behind the knee to insert above the attachments for soleus. So this would be the soleal line on the back of the tibia. Its whole purpose, other than, I guess, flexion of the knee, is again to reach up, grab the femur, and externally rotate it to unlock the relationship between the femur and the tibia. Okay, so it's an unlocking mechanism to then allow you to start, let's say, walking. The three deep ones, flexor digitorum longus, most medial aspect of the muscle, curls around behind the medial malleolus to enter into the foot. Becomes four tendons that go to the lateral four toes, the distal phalanx of the four toes. So it's not that big in size compared to its buddy, the flexor hallucis longus, which is more lateral and quite significant in size. It likewise curls right behind the malleolus. It actually has a groove in the talus that's quite substantial. Before it swings into the foot, it goes down and inserts onto the distal phalanx plantar surface of the big toe. And again, it's about 1.5 times the size and cross-sectional area to digitorum. Although digitorum goes to four toes, hallucis only goes to one, it's much, much bigger. And so it's going to plantar flex the big toe. It's also going to plantar flex the metatarsophalangeal joint because it passes behind the ankle. Both it and digitorum would be weak plantar flexors, pretty close to the ankle. And you don't really need them because you can triceps suri and do all the ankle plantar flexion you want. Deep to those two, if you pull them apart or separate them, right along the interosseous membrane is tib posterior. So all of these except popliteus have nothing to do with the knee. They cross, so tib posterior will cross right behind the medial malleolus, and then it comes down and inserts into the foot sole in a very complicated way. Because it passes behind the malleolus, it's a weak plantar flexor, but mainly because of its attachments on the top part, undersurface of that arch. When you contract it, its whole job is to keep the medial arch from collapsing. That and TA work together. Okay. We'll see that in a bit. All four, tibial nerve. Okay. Showed you a slice from actually Moore's fourth book, just to talk about the area of interest, because I have focused on everything from popliteal fossa, femoral triangle, you name it. But this is a nice view showing you first where extensor hallucis would go. Then here's the tendon for tibialis anterior, where it would attach. You can see, oh yeah, I can see how that's going to want to invert the ankle. Then we come to tib posterior and its attachment. You'll see again in a second how complex that is. We then have tendon here, number 4, flexor digitorum longus tendon. It's going to come down into the foot and then shrapnel to those 4 tendons that go to the lateral 4 toes. And finally, flexor hallucis longus. It's actually farther away from the medial malleolus before it finds its way all the way down to the big toe. In this area, underneath the flexor retinaculum, which is basically helping to guide all these things, you could have the posterior tibial artery as it comes down before it branches two parts that supply the blood to the foot, and the tibial nerve before it breaks into its 2 branches, the medial and lateral plantar nerves, to supply all those intrinsic muscles we just about to talk about. Okay. So this is the figure from Moore. The reason I like it is these bottom 2 really clearly show you how complicated the attachments are for tib posterior and for fibularis longus. So first, we have the tendon coming in of the digitorum, comes in at an oblique angle The neat thing about the foot is rather than the hand, where everything can basically cross through the carpal tunnel right in the middle of your arm into your hand, you can't do that with the foot because you need to weight bear. So stuff goes to the lateral side, the fibularis muscles, and a lot of stuff comes to the medial side of the malleolus and bypasses the heel before it enters the foot. So you get this funny angle of the tendon and digitorum coming into the foot, and now it's going to give off its four tendons that go to the distal phalanxes of the lateral four toes. It's got this kind of 45-degree bend it has to deal with, and it's going to have help from the intrinsics to do that. The flexor hallucis longus tendon goes all the way down here. If you remove those two, now you can see a little more clearly the strange and complicated attachment for tib posterior on the medial side under surface of the arch. So it attaches to a whole bunch of stuff. And again, feel it's primarily pulling up on the arch. So it's probably active right now. As soon as they start to weight bear, it's going to become more active. They weight bear more on this side, it's going to become more active. Airborne, maybe not, right? We come on in anticipation of weight bearing, which is probably something that people do get in trouble with. So heavily supportive of the arch. The other one is the fibularis longus tendon. It's going to come along and groove, and there's a big groove right in the cuboid, the underside surface of the cuboid, and race across the sole of the foot to attach medially. So it's going to come in laterally, go at an angle, so it's still going forward, but laterally, well, medially, sorry, to the medial side of the foot. So you can see how this pulley that's in cuboid is going to allow the fibularis longus to be a very good everter of the foot. And because it also runs along here, these two, tib posterior and fibularis longus, are really going to help support the arches right here, the transverse arch. So not only are the two arches going front to back, there's one that goes right across the middle of your foot. So the lateral part of your foot is lower than the medial part of your foot. So there's a lot of arches going on in the foot. Okay, this is where we left off. So the muscles in the sole of the foot, there's 20 muscles in total in the foot. But we already talked about the two in the dorsum, extensor digitorum brevis, extensor hallucis brevis, both supplied by deep fibular, right? All these other ones in the sole are supplied by branches of the tibial nerve, the medial plantar and the lateral plantar, kind of like the median nerve and the ulnar nerve in the hand. So if you can remember the four muscles that are supplied by the medial plantar nerve, everything else is supplied by the lateral plantar nerve in the foot sole. Okay. So the first layer, we have three muscles. Abductor hallucis, so instead of pollicis in the foot, it's the hallucis. It's going to run from the lateral side of the calcaneus all the way up to the base of your big toe and attach at the proximal phalanx, basically the base of proximal phalanx. Okay. So in contrast to the hand, the toe is tightly bound to the foot, versus the hand, which we have this amazing dexterity with opposition and movement of the thumb. Don't have that in the foot. So although it is an abductor, people can actually work at it. You get pretty good at abducting your big toe away from the midline. It's actually also a very good flexor. Okay, so it'll help flex the big toe. Next to it, flexor digitorum brevis. So this one actually takes its attachment from within the foot. It's an intrinsic foot muscle. From the base calcaneus more to the medial side, runs up, breaks into four tendons, and they pass forward and they split to insert into the middle phalanx on either side. And they allow the tendon, the deeper tendon of the digitorum longus, to go all the way up to the distal phalanx. Again, you can see the analogy between superficialis and profundus in the hand. Okay. Superficialis is the one that has to split, because profundus is deep to it before it inserts into the distal phalanx in your fingers. Same design here. The difference is this guy actually resides right in the foot. Okay. You can see how the two of them are going to work together to, well, longus is going to flex the distal phalanx, and this guy here, the digitorum brevis, is going to actually grab the middle phalanx of the four toes. Working together, they're going to also do what? Massively support the arch, both medial and lateral longitudinal arches. Both of these are medial plantar nerve, so they're the first two that get medial plantar innervation. On the outside of the foot, abductor digiti minimi. Again, more from the lateral surface of the calcaneus all the way up to insert base lateral surface of the baby toe, proximal phalanx. So again, some people are really good at splaying their toes, especially big toe and baby toe on. But because it's on the end, on the deep surface of the foot, it's also pretty good at flexing the toe. And like the other two, they all are going to help to pull what? Try to pull the toes towards the heel, again, supporting this arch. Second layer, only 5 muscles, but 4 of them are easy to remember. There's the lumbricals, and they each come off of the tendons of flexor digitorum longus. In the hand, lumbricals come off profundus's tendon. And the foot, they come off the flexor digitorum longus tendon. They come off, and they do exactly the same thing as they do in the hand. They spiral around in between the toes, so the first one will go between the first toe and the second toe, and insert on the top onto the extensor expansion, just like the first one does in the hand. The other 3 do exactly the same thing. The first one is unipennate, not that you have to know that bit, so it only has one attachment to the second, for the first tendon of flexor digitorum longus before it curls around. The other 3 are bipennate, meaning they take attachments to both tendons. So this one will attach to both these, this one will attach to both these, this one will attach to both these. Doesn't matter, they all curl around and insert into the dorsal expansion. So they're running from a tendon and inserting into a tendon, just like in the upper hand, or the upper limb in the hand. The first lumbrical is supplied by the medial plantar nerve. Okay. The other 3 are lateral plantar. So that's the difference from the hand. Remember, the hand, 2 lumbricals are median, 2 are ulnar. And here it's only the first one. It's only the first lumbrical that's supplied by the medial plantar nerve. The other 3 are lateral plantar. They do the same thing. Okay? They're going to want to flex at the metatarsal phalangeal joints in your toes and extend the phalanxes of those 4 toes, just like they do in the hand. Okay? Running from the heel, so what they've done is they've removed the flexor digitorum brevis so you can't see it. It's gone. Deep to it, and running from the calcaneus up, and actually inserting directly into the tendon of flexor digitorum longus is a muscle called quadratus plantae. So it's coming off the heel, ripping forward, and attaching itself to flexor digitorum longus. Now remember that tendon as it enters the foot from medial heading laterally, and then sprouts these 4 tendons into the toe. So what this muscle is doing is it's going to pull on that tendon to help line the forces up from the 4 toes back towards the heel. It's going to make flexor digitorum longus more efficient at flexing directly along the line of the foot. Okay, that's kind of cool. So it's intrinsic. It's also supplied by the lateral plantar nerve, and these 2 groups make up the second layer. Now I've highlighted in green box here, flexor digiti minimi brevis. It's a small muscle on the side. I've highlighted it here because the next image, he doesn't label it, I don't know why, but it is a part of layer 3. Okay. So we go to layer 3, here is flexor digiti minimi brevis, right there. Okay, so obviously it's a tiny muscle, it inserts up where the abductor will insert, kind of on the lateral surface, the base, the proximal phalanx of the little toe, but it's going to be primarily better at just flexing the toe. It's much smaller in size than the abductor was. Okay. So that's one. It's going to be supplied by the lateral plantar nerve. So I'll go back to the previous slide and show you right there. So it's going to be supplied by the lateral plantar nerve, and it's a part of layer 3. Okay, the other 2 muscles that are in layer 3, well, there's an adductor hallucis, kind of like we had in the hand. And in fact, it has 2 heads, just like the hand. It has a transverse head, and it has more of an oblique head. The difference is, the big toe isn't that mobile. So this one doesn't have to do a lot of work trying to adduct the thumb or bringing the thumb back to the palm. In fact, probably what it's doing is helping support the arch that's now going along the heads of these metatarsals and helping to pull the toe towards midline. So keeping this as a solid and rigid structure. They insert, both heads come together and they insert on sort of the sesamoid bone and the medial surface, proximal phalanx of the big toe. This one, like the flexor, is supplied by the lateral plantar nerve. Okay. The third muscle in the deep layer, flexor hallucis brevis. So just like in the hand, there's one for the big toe. Just like in the hand, this one has two heads. So the difference is the two heads go to either side and attach through the sesamoid bones to the base of the proximal phalanx. And this one is your last muscle that's supplied by the median plantar nerve, or medial plantar nerve. Okay, so we have flexor hallucis brevis, adductor hallucis, the one with the lumbrical. What's the last one? Right out the door. No one got it. Flexor digitorum brevis. If you remember those four, remember their medial plantar. Everybody else has to be supplied by lateral plantar. Yes, sir.
For these physical muscles, we have to know proximal distal attachment.
Again, some are easy, right? So that's dead easy. The adductor would be dead easy. Some of them aren't. Things like flexor digitorum brevis, yeah, it's the only thing that attaches here. So those would be fair. They're multi-worded attachments and more because they're coming from this cuneiform, that cuneiform, the posterior lateral surface of that cube, you know, no. Those are just like the ones from the shaft of the tibia, too much, if you remember. Okay, 3 layers. What's the 4th layer you think? Take a guess. No, lumbricals are second. Interosseae. Just like in the hand, there's going to be 3 plantar, not palmar, and 4 dorsal. Okay. Now the difference for the toe, remember when we do abduction and adduction of the hand, it's all about that middle finger. So if you think about it, you can go, okay, I'm going to put my hand in an abducted position. I forget I have it found because that's got its own machinery. How do I get my fingers towards the midline? Right? How do I pad? Well, one has to do this, one has to do this, one has to do that. So that's how they're set up in the hand, the 3 of them. In the foot, the point of everything is the second toe. The second toe is actually the longest toe you have. You stand barefoot, look down. The second toe should protrude just slightly beyond the first toe. First toe is bigger, thicker, but it's not as long. Okay? So what you have to do is bring the 3rd, 4th, and 5th toe towards this guy. Okay? So that's where these adductors are. They're green, they're just like in the hand, they're guinea-pennied. Okay? And they're, if you remove all the other stuff from the sole of the foot, all the ones we just talked about, those first 3 layers, those 3 are the first ones you'll come across. Okay? So they're going to try and move the toes towards the second toe. The big toe, it's got its own adductor, remember? Adductor both transverse and oblique head, so it doesn't need to have a kind of interosseous attachment. You remove them, or you come from the top down, either way, you now have 4 bipennate muscles called the dorsal interosseae. And again, the focus here will be the second toe. So now you have a muscle on one side, the first one will abduct, or try to pull the toe towards the big toe. The other side will try to pull the toe towards the 3rd toe, etc., etc. So 3 and 4, again, trying to splay the toes. So some people are okay at doing some of that, but if you notice, all these muscles, your feet aren't as dexterous as your hand. So the bulk of what these guys do is support the bones in the foot to tolerate loading. So there's a whole control mechanism on these muscles where they're turning on during weight bearing, okay? And they're probably designed to basically hang on to everything they've got and keep them from going apart, okay, not necessarily moving. Some of the ones that are associated with the big toe, maybe they help push off in walking. So the adductor probably does that. So, same idea as the hand, just remember, if I'm trying to move it above the big toe, or the second toe, where would they reside and how would they act? all of them lateral plantar nerve. Okay? Remember, in the hand, all the interossei, all nerve. So you can see the analogy between the medial plantar, median lateral plantar, and ulnar nerve in the hand, and some of the muscles as well. Okay, so this is the figure for Moore, same thing, just all 4 layers, nicely documented for you, so you can see them quite clearly. And in this one, he's actually got, flexor digitorum brevis in the foot, in the 3rd layer where it belongs. Now, why it's called brevis? No idea. There's no longus, but it is. Okay, so just remember that. Okay, the relationship between the tibia and the fibula. So again, if you remember in the arm, that superior radial ulnar joint is really kind of groovy. Got that round head for the radius. You get the angular ligament all around it. The whole thing can spin. It spins in relationship even to the humerus. Humerus, the capitulum comes down, you got the head of the radius, it can pivot right around that thing. So you've got the ability in the arm to supinate and pronate, okay? The distal one, still highly mobile, allows basically the ulna to stay still and the radius to rotate over top of it. So they're much more mobile than you'll find in the lower limb. So the proximal joint is a synovial joint. There'll be a cavity in there with articular facets interacting, synovial membrane. It has a posterior ligament of the head of the fibula and an anterior ligament of the head of the fibula on either side. So they basically bind the head to either the posterior or anterior surface of the tibia fairly significantly. They are quite thick. But again, it's a synovial joint. You go down to the distal one, okay, where basically the tibia has the medial malleolus and the fibula contributes to the lateral malleolus. This one is bound tight. Okay. It has a posterior tibiofibular ligament and an anterior tibiofibular ligament. And in between the two is a very dense interosseous tibiofibular ligament. So it's going to really try to anchor these together. So that usually doesn't come apart. Okay, either front or back, it's going to stay. What unfortunately happens is above it is where the fibula will fracture, or we shear off the head of the lateral malleolus for some reason. But this stuff usually never gets separated because these 3 ligaments are incredibly strong. They're rigid, they don't allow a lot of movement. Okay? You can get a bit of movement up here because it's a synovial joint. So when you dorsiflex, you bring the talus into between the 2 malleoli, you kind of start to push them apart. Some of the fibula might glide a bit on the superior posterior aspect of the tibia might move. We're talking a millimeter. Okay? Most of these very, very solid joints. And if you notice, again, tibia goes right down on top of the talus. That's where all the weight goes. Fibula, not. It's kind of going along for the ride. Gives you a place to put a lot of muscle attachments and to share some of the load. Well, how does it do that? There's an interosseous membrane binding the two all the way down. And if you look at a cadaver or some of these schematics, the fibers run from the tibia to the fibula in a downward direction. Okay. And they continue on as a part of this interosseous tibiofibular ligament. So they carry on right in through here, binding the two together at an angle. What that angle does is it sort of suspends the fibula on the side, and any kind of load or impact that comes through the tibia is transferred over to the fibula, and the fibula is pulled up in the process. So that's how the fibula actually helps to support you. It doesn't just give purchase to muscle, it actually takes some of the impact as well, because the tibia can shunt it through this interosseous membrane and pull on the fibula, although the fibula doesn't take any direct load through the limb. Okay? So a very important joint, but not a whole lot of mobility involved in it. Here's a nice image, a radiograph, showing you basically what's called the mortise, or the malleolar surface of the ankle joint. So this would be the head of the talus, and its body down here. Here's the fibula, here's the tibia, and so this would be the medial malleolus, this would be the lateral malleolus. And if you look, there's a growth plate right there, in the bottom part of the tibia, and there's the growth plate in the fibula. So this is an individual pre-puberty. They've taken an X-ray, you can actually see them. They're not fractures, they're growth plates. They're cartilage that allow the bones to grow. there's an adult, those would be just solid line. Okay. So, reviewing our retinaculums, now that we've learned them all, you're going to have some on the superior surface and the inferior surface that help with the extensor tendons. You're going to have one on the medial surface called the flexor retinaculum. And then here, down here, you'll notice the terminology, inferior and superior perineal retinaculum. Remember, that's an old term for fibularis. So, you know, the inferior and superior fibular retinaculum are the ones that help to basically control those two fibular muscles, brevis and longus. So, we start talking about the joints now in the foot. There's tons of them, right? I only carry about a few. So the first one, the most important joint you have to deal with, obviously, is the relationship between the tibia and the talus, and indirectly the talus with the fibula on the outside. So the fibula contributes by giving you that lateral malleolus. The tibia gives the contact with the talus, and then that styloid process, basically, that chunks down on the inside, called the medial malleolus. If you look at the skeletons, you realize that the lateral malleolus extends a good centimeter below the medial one. So they don't stop at the same height. There's quite a big difference between how far the fibula goes down on the outside. Some of that restricts eversion of the ankle. Okay. So this joint, sometimes called ankle or talocrural joint, so that's the tibia and the talus, that's important for plantar flexion and dorsiflexion. That's allowing you that hinge joint. It's a synovial joint, big thick capsule, lots of synovial membrane in here. Okay? And it's going to be allowing you to do plantar flexion and dorsiflexion. But if you look, and so this is the anterior surface, the inferior surface as well. If you look at the talus in the lab, what you'll notice from a bird's eye view kind of has that view. This would be medial, this would be lateral. It's not square. The front part of it is wider, way wider than the back part. So if you move the talus in dorsiflexion up in between the two malleoli, it kind of gets wedged in. So at the end of dorsiflexion, two things prevent you from going further. The calf muscles, if they're tight, will restrict your range into dorsiflexion. You cut the Achilles, so it's not there. Maybe some of the other muscles might restrict it. But what's really restricting any further motion is you just jammed the talus in between the two malleoli because it's wider at the front. As you do that, as you jam it in, that's when you might get a bit of motion occurring at the fibula at the top. Okay? So if you put it the other way around, if you plantar flex, okay, as you plantar flex, the malleoli now have much bigger space between them and the medial and lateral malleolus. Okay, sort of the talus is narrower at the back. So if you plantar flex, you can test someone. Just take them in the lab, put them in a dorsiflexion, just try to play around with their ankle. It's going to be tight and stiff. Put it in a plantar flexion, ask them if they sprained their ankle first. Just, you know, and play around with it. You'll feel that the ankle joint now, the talocrural joint, becomes really, really unstable. Why? Because there's so much room in the back between the narrow part now of the talus, lateral malleolus, and medial malleolus. So think about it. When do you sprain an ankle? Well, you can either do it this way, just pure inversion, or that, right? Toe down, plantar flex, inversion, supination, everything going on at the same time. That's usually when people will blow out an ankle laterally. It's that position. Not usually these. You do other things when you just pure inversion. Okay? So the talocrural joint is really important for plantar flexion and dorsiflexion. So how do you get the inversion and eversion? Where does that come from? Well, it doesn't come from the talocrural joint. It's not supposed to. Remember, the talus is right in between these two malleoli. It's not going to be able to roll that much. There's a bit of movement, not a lot. It's the relationship between the talus and the calcaneus, what's called the subtalar joint. So subtalar, right between where the talus sits on the calcaneus, is where a lot of motion can happen when you invert your foot. So you can really invert your foot quite a bit. Okay. Well, I don't try too hard. You can really invert quite a bit. And that's occurring one place is the subtalar joint. The next joint in question is one called the transverse tarsal joint. You take the joints between the talus and the navicular, calcaneus and the cuboid. You draw a line right through it. That's what he's calling the transverse tarsal joint. It separates the talus and calcaneus from the next two, navicular and cuboid. This is another highly mobile joint. And so the two of them, subtalar and that one, transverse tarsal, that's what's allowing the foot to do this fantastic thing of inversion. Okay? That's where the bulk of the motion is. That's also why you can't invert as much. So in the lab, just pick up a foot and try and, even the models, just try to invert a bit. You realize there's just not a lot of play that way. Okay? It's really hard to invert the ankle. You get a few degrees, that's about it. So other joints are all listed here. Some of them are very obvious. The talocalcaneonavicular. That's a tough one to think about. I don't know why they call it a joint, because if you look in the lab, the calcaneus never touches the navicular bone. Gets close, a little gap between the two. But in real life, there's a lot of stuff in between. So they call it a joint because I think it's one of the critical joints in transferring weight. It's basically the talus shunting weight to the two of the other ones. But it's the anterior part between the talus and the navicular and the cuboid calcaneus over here. That line creates this transverse tarsal. That's really important for inversion and eversion in the foot. Then the other ones are pretty obvious. I mean, there's going to be a joint obviously between the navicular bone and the three cuneiforms. There's going to be a junction between the cuboid and the lateral cuneiform. There's going to be junctions between the tarsal bones and the metatarsal heads, between the metatarsals themselves, and then we get the knuckles, etc. So here's the metatarsal, flanges, interphalangeal joints, etc., just like in the hand. We don't need to know all the details of that, but I do think it's important to understand the relationship between the talus, the navicular, calcaneus, and cuboid, because they are the ones that allow you to not only invert and evert. And you're going to see all kinds of terminology going forward, so I'll try and keep it simple. Inversion and eversion, okay, is in the coronal plane, frontal plane. So when you invert, it's taking the anatomical position and turning the sole that way. When you evert, you're trying to turn the sole the other way. You're going to hear the terms supination and pronation. They're not the same as that. Okay. When you land on body weight and you plantar flex, and that medial arch kind of collapses a bit, that's pronation. As you step off, you bring the arch back up, and all these other joints, the distal joints, start to go back into their arch shape. That's supination for the foot. It's very different than this. Same idea. So if you have anti-pronating shoes that are supposed to keep you from pronating, they have a high medial arch and they're stiff. Why? Because they're trying to prevent collapsing of the arch, which is pronation. Okay? So pronation, supination, eversion, inversion are the same for anatomical motions. Okay. Yeah, let's do this. So, ligaments in the ankle joint are just like everywhere else. There's a big connective tissue capsule around the ankle. It's pretty baggy on the front, pretty baggy on the back in places. So that allows a lot of plantar flexion and dorsiflexion. But on the lateral side, the capsule thickens in three distinct locations that form the lateral ligaments. And if you've ever had an inversion sprain, you've probably damaged one or two, hopefully not all three, of these ligaments. So the thickening of the capsule, there's an anterior talofibular ligament, so it's going to run from the talus laterally and attach to the anterior part of the fibula. Okay, it looks like it's horizontal. It's not. Again, in the lab, if you look, it runs at least at a 55 to 60 degree angle from the front of the talus out here to attach to the fibula. Likewise, its compatriot is the posterior talofibular ligament. This can run from the posterior aspect of the talus out laterally, superiorly to attach to the fibula. It's almost running horizontally like this. Okay, so again, if you look in the lab, you realize it's not like that. It's this way. And And lastly, there's one that comes superiorly from the calcaneus, calcaneofibular ligament, runs up from the calcaneus, up, attaches to the tip, basically, of the fibula. Likewise, it's not running vertically, it's running kind of up at an angle. So they all have this kind of angle to them, and that's what jeopardizes them when you sprain your ankle. They're not straight. Okay. Two little ones, well, one little one, lateral talocalcaneo, just helps to bind the talus and the calcaneus together. But if you notice in the lab, there's a big hole called the tarsal sinus in the ankle. You look at the ankle, there's a big kind of sinus between the tarsus and the calcaneus. That's the subtalar joint. Within that, very important interosseous talocalcaneal ligament. It's thick, and it helps to really anchor the talus and the calcaneus. Doesn't prevent them from rocking on each other, which is inversion and eversion, but it helps hold them together. That one's actually pretty important. Okay, the other ones we've already talked about, anterior tibiofibular and posterior tibiofibular. So notice on the lateral ankle joints, this one, I will get sticky, is it's going from the tarsus to the fibula, talofibular, calcaneofibular, not fibulocalcaneal ligament. Wrong. You have to remember. So for the lateral ligaments, it's the tarsal bone to the fibula that counts. When we swing to the medial side of the joint capsule, basically from 3/4 away across the anterior surface all the way along the medial side is a massive thickening of the joint capsule in the ankle. So very, very strong ligament. It's on the inside of your ankle joint, not on the outside. And it's called the deltoid ligament or the medial ligament of the ankle, and you can break it into 4 parts. On a cadaver, it's just one continuous hunk of tissue, but somebody's decided to say, okay, depending on where it runs, I give it a distinct name. If it runs anteriorly from the tibia to the talus, we call it the anterior tibiotalar part of the ligament. If you come backwards, now there's tibio-navicular, so the part of the capsule that actually ties the tibia to the navicular bone. Next to it, part of the capsule runs from the tibia down and attaches just above the sustentaculum tali to the calcaneus, tibiocalcaneal. And then as you swing around to the back, the posterior aspect of this capsule, posterior tibiotalar. All 4 of these are this medial ligament, or sometimes you've heard the colloquial term deltoid. But notice, the game just changed. The direction is now from the tibia down to the tarsal bone. So it's tibia something, tibio something, rather than on the lateral side where it's the tarsal bone to the fibula. You have to remember that, I'm sorry. You can't tell me the other way around and think it's right, because it's not. It's not anatomically correct. Okay? These 4 really help thicken the medial side of your ankle joint. That's why people almost never actually sprain the medial ligament. They break things, but they don't sprain that ligament because it's so thick and very strong. In this slide, we'll just cover 3 more ligaments. Like on the outside, there's a lateral talocalcaneal ligament. There's also a medial talocalcaneal ligament. There's also a posterior one. But two ligaments that are really important when we get to this next week on Monday, when we finish off the arches. The long plantar ligament. It runs from the calcaneus all the way up and inserts into the cuboid. It's a big band, and we'll pick that up again in the next class. Very strong, and you can see what's it trying to do. It's trying to keep the calcaneal heel tied in to the cuneiform bone in front of it, and cuboid on the other side. So you can see it's like a tie beam on a bridge. It's trying to prevent this thing all from collapsing. Lastly, there's that ligament that fills the gap between the sustentaculum tali and the navicular. Remember, in here is the head of the talus. And in fact, there's nothing there. There's no bone for it to interact with. Instead, there's a bridge that's built between the sustentaculum tali and the navicular to help support the head of the talus here. And this is called the spring ligament, or calcaneal navicular ligament, plantar calcaneal navicular ligament. This one is quite strong, unfortunately not as strong as it should be. So still, if you have flat feet, this is so weak that the head of the talus starts to pop through. It actually comes lateral to the ligament, and you end up with a collapsed medial arch. So these 2, the spring and long plantar, you can just see how they're designed to really help keep the medial longitudinal arch up and prevent the talus, which is getting a whole lot of stuff coming down on top of it weight-wise, from pushing through that gap. Okay? So, yes, do this one, just so we can see the different angles. If you look, here's a really nice angle for the lateral side, the calcaneofibular ligament. Okay. You can see it's going superiorly, but it's also going out and attaching out here. Look at the posterior talofibular. It looks like it was going forward. It's not, it's going like this and grabbing the fibula. Very interesting lines to support. You can also see from the delta ligament, the medial side, you can just see the last posterior aspect of the lead tube. Okay, so there's the posterior tibio-talar and the tibial calcaneal that goes to the calcaneus part. And so they thicken, but they don't complete the posterior aspect of the capsule. The capsule there, it's there, but it's pretty thin. Now, remember we have this ligament binding the fibula and tibia together. Some of it extends down behind the mortise of the talus, or the head of the talus, the body of the talus, the trochlear part. So it comes in behind it. So in fact, there's a bit of a cup that's ligamentous behind your talus. So it's actually really hard if you have someone in a neutral position to try and push the talus posteriorly. It doesn't want to go that way. First off, the front of the talus is thick, so it doesn't want to get pushed through. Secondly, there's a bit of connective tissue in the back that's quite strong, so it's really hard for you to basically pull the tibia right across the talus. It's possible, it's not for it, for that to happen. So this angle really helps to take those lateral views of the ligaments and put them into 3D perspective. Because it's important. What happens if you all of a sudden invert too much? Goodbye. Right? It's going to pull. We'll talk about it next class. So there will be a lecture on, this is the slide from your more 6. There'll be a lecture on Monday. We might get through everything by the end of Monday. We'll see what we do with Wednesday and Friday. What I might do is on Wednesday, do everything before the midterm, and on Friday, everything after the midterm, in summary. So, you might like that, or you might fear that. So Wednesday and Friday, you can come if you want to hear summaries and ask questions for clarification. But if you think it's going to just destroy your mental attitude, and you'll say, I'm going to go and study instead, then you're free to do that. But Monday, we'll have a lot of stuff, okay?